Okay, good afternoon everybody. It is time to begin. Very important lecture today, something which will lay the foundation for a lot of stuff we will be covering in chapters 4 and then chapters 5. So this is something you definitely should get to understand very well. Hopefully we will go slowly enough so you guys could understand all that. First, let's go back a little bit and refresh your memory about some of the stuff we did last time. Do it all on the board. So once again, this is what you should know by now. This is an important stuff from the previous week. We have 4 types of prepositions. Remember A, E, I, and O. A prepositions are all SRP. E prepositions are no SRP. I prepositions are some SRP. And finally, O is some S are not P. This is what you should know. You should remember that. And it's best to arrange them like this. Also remember that these 2 are universal and these 2 are particular. Also, what you should know now is that we can actually graphically represent them, and we were doing it like this. In this case, this is P and the S is inside. All S are P. In this case, like 2 circles, S and P, completely separate. In this case, we have a circle of P, and we have a little S inside of it, just an X here. And in this case, again, we have a circle P and a little X for the S outside of it. This is essentially what they are. This is what they mean. This one means all S are in P, no S are P. This one means there's at least one S which is also P, and this one means there's at least one S which is not P. Okay, now remember we were also talking about Aristotelian and Boolean standpoint. We're talking about existential import. First thing to remember, it only applies to these 2. Only these 2 have a difference between Aristotelian and Boolean standpoint. For the particular ones, there's no disagreement. Particular ones, both Aristotelian and Boolean standpoint agree that they always have existential import, which means we always assume that S-class exists when we put the X. How about these 2? There's a difference. What is the difference? Aristotle says that we only assume existence here for class S in cases when whatever S is actually exists. So if we're talking about cats, we do assume existence. Tom Cruise's movies, again, we do assume existence because they exist. But if we're talking about witches or unicorns, we do not assume existence because they do not exist. From Boolean standpoint, on the other hand, we never assume existence regardless of whether we talk about Tom Cruise's movies or witches or unicorns. Just by default, never assume it, and that's it for these 2. Okay, this is the kind of stuff you should understand by now and remember. The first slides here there are simply repeating that stuff I just told you. So A and E, when things exist, Aristotle says we assume existence, and that means they are considered open for existence. Boole says, no, we never assume that, so they are closed for existence. So this is for A and E. For I and O, they both agree, we always assume existence. If we say some cats are animals, that means there's at least one cat. If we say some fish are not mammals, we assume that there's at least one fish. And by the way, if we say all wizards are smart, we assume there is at least one wizard. Except in which case that will be a false statement because there are no wizards. Okay, Venn diagrams. What are the Venn diagrams? This is something which will help us to evaluate truth values of propositions and make inferences and understand why in particular a particular inference is valid, why can it be invalid. It will be more important in chapter 5 because we will start talking about syllogisms. Remember what the syllogism is? It has 3 parts, 2 premises and 1 conclusion. So it will get a little more complicated, and for this we will need them especially. But even in chapter 4, it's a preparation for that, you still do need them. So what are the Venn diagrams? John Venn is the person who kind of invented them in order to simplify our job. This is what you always start with for all 4 of them. Instead of the stuff we are drawing up until today, we will replace it with this kind of universal way of representing the 2 classes, class S and class P, 2 overlapping circles. Probably a hard part for some students is to draw that. Well, we will not be drawing that many of them, although I definitely want you guys to have a pen and a paper there handy so that you would be able to do the exercises and do all that for yourself. So don't just watch it, make sure you actually have some drawing material. Okay, what do they mean? Well, basically if we draw 2 circles like this, and class S for us will be Americans and class P will be farmers, this is what it would mean. We will have 3 areas inside the circles and a 4th area outside. Class 1 would be Americans which are not farmers. Class 2 would be Americans which are also farmers. What do you think class 3 will be? Exactly. Those farmers who are not Americans, like all the rest of the farmers, French, Mexican, whatever else. How about 4? What would be 4? 4 is outside of both of the circles, so it will be what? Neither farmers nor Americans, so in other words, all the rest of the people in this world who are neither farmers nor Americans. For example, French construction worker or Russian truck driver. All these people would be in 4 because they are neither Americans nor farmers. And note that this is actually the largest group. But for our purposes, of course, if we have 2 classes, we'll be just dealing with these 2 classes rather than with whatever is outside of it. But you have to keep in mind that there could be something outside of them too. In most cases there is, of course. How do we mark them? Well, we have 2 types of markings, shading and an X. And the shading will tell us that there is nothing there, and an X will tell us that there is at least one thing there. Now, keep in mind that if there is no mark, it does not mean that there is nothing there. It just means that there could be something there, or there could be nothing there. Okay, so let's look back at this drawing we had and understand how it works in terms of what we have. So we used to do it like this, right? 2 circles, one inside the other. Now we will represent the same idea with the 2 overlapping circles. And it is really simple. If you have a circle S and the circle P, what you actually have to show is that whatever S there may be would be inside P. So you block completely this area here. That means there's nothing there. Note that we don't know if there's anything here, but we are saying if there is something here, that would be both S and P. And here that would be just P. Equally in this case, we again have to start with the same two circles overlapping each other. But now we have to show that there's no common area. How do we do that? Well, we just block out the middle part, the overlapping part. We block it out, showing that there's nothing there. Again, is there something here? We don't know. That's all it tells us. We don't know if there's something here. How about the other two? Well, it's actually a little bit easier. Now, instead of that, we can just draw the S circle right here. And so we can even leave this X, and it will just be telling us that there is at least one thing here. Let's put it in the middle. Get it a little nicer looking, but the same idea. And equally here, we draw another circle, S circle, and we put our X like here. Same idea. We are showing that there is at least one thing in that area outside of P circle. We have at least one thing here which is both S and P. We have at least one thing here which is S but not P. And that's it. So it's kind of a nice and easy unified way of drawing all four of them. Okay. This is all of them the way they are in the book. I would prefer to see them like this in a square rather than one after another, but it doesn't really matter. This way it just will be easier for some of the other stuff we'll do later. The idea is the same now. This is A, all S are P, left side is shaded. This is B, no S are P, middle is shaded. This is I, some S are P, middle has an X. And this is O, some S are not P, so we have an X here on the left side. Okay, the first extra credit exercise, you need to draw a Venn diagram for this rather simple proposition. All electric motors are machines that depend on magnetism. Note that instead of S and P, you're using E and M. Electric motors would be E. Machines that depend on mechanism would be M. Doesn't really matter what you name them. This is your subject term, this is your predicate term, right? So this is the left, this is the right. How do you do it for extra credit? Well, the easiest way for us to proceed will be like this. Just tell me based on numbers. If this is the two circles you draw, this is 1, 2, and 3, right? Same idea we just saw. The area is 1, 2, and 3. So for example, you can tell me area 2 is shaded. Nothing in 1 and 3. So the first person to do that correctly will get an extra credit. Yes, Sarah is right. Susanna, you are not right. I just gave it as an example. This is not what it is. This is all ERM. So area 1 should be shaded. See, it's an A. It's an A-type proposition. It should look like this. Okay, so good job, Sarah. You have to remember these 3. And in fact, for you, it's even a little bit easier. Cool, Sarah, you got the 5th one. You have complete 5 now. That's the last extra credit for you. Okay, well, more extra credit for everybody else. So, yes, this is the picture. Let me go back to this picture. This is how they're supposed to be. You actually should draw it for yourself. When we had it in class, students were supposed to remember it. You have it much easier. You can just put it on your notes and have it for exam, for homework, for whatever else you want. But you have to remember this is how it looks like. This is A, this is E, this is I, and this is O. Shading, shading, x, x. Okay, let's go back. Let's do this one now for two of them. This and this. And again, extra credit. So if you got it, you should be able to get this one. A little more challenging than the previous one, but not all that difficult. Same principle, same idea, except 2 instead of 1. Okay, I guess that's another way to put it, but note that it is again correct. So x in the middle for 3 and middle shaded for 6. For some reason it doesn't look good on that slide. I don't know, it printed it somehow weirdly for PDF. But you can see the x here, right? This is a tiny little bit of x sticking out. This is an x in the middle, and this is the shaded part. Okay. So, good job, Jacob. No, you also got your last extra credit. People who were close are now done. Okay. Again, more opportunity for everybody else. Now, the contradictory relations. Let's go back to the board to understand what is going on here. Note that this is what you can immediately say by looking at them. A tells you this part is blocked, but O tells you there's an X here, there's something there. This one says there's nothing here, this one that says there's something here. So we call them a contradictory propositions, and it's a contradictory relations between A and O. Now, you can immediately notice the similar thing for E and I. E says there's nothing here, I says there's something here, so these two are also contradictory. What does that mean for our purposes? It means the following. If A is true, O will necessarily have to be false. If A is false, O will necessarily have to be true. Equally, if O is true, A will have to be false, and if A is false, O is false, A will have to be true. And the same here. If E is true, I is false. If E is false, I is true. If I is true, E is false. And if I is false, E is true. So the value changes. It has to change from this to this. Note that this is the only two relations we can draw from that. Or we can jump in ahead a little bit, look at the other four relations, right? Because it's a square, you go in like this, you can also go like this. Can you? No, you cannot. Because whether or not this is true, this one not going to tell you anything about the value of this one. Same thing going from E to O, same thing going from O to I, and from I to A. So this is kind of the moves you cannot make. This is the only two moves you can make, from A to O and from E to I. And every time you make this move, you have to change the truth value from whatever it is to the opposite. Okay. Now let's go back to the slides. So again, A and O, contradictory. E and I, contradictory. The truth value changes for contradictory from whatever it is to the opposite. All the other ones, these dashed lines, they are logically undetermined truth value, meaning that when you, for example, go from A to E, you do not know what will happen to truth value. And that is what is known as modern square of opposition. Note that you have A, E, O, and I. Know that you have this relation I told you about, contradictory relation going across. That will mean that you change in the truth value. If you have I going to E, you have to change the truth value. If you have E going to I, change the truth value. And again, note that the dashed lines mean logically undetermined, meaning you cannot make these moves. These moves are not allowed. If you try to do them, you will have invalid inference. Vacuously true and false. What does that mean? Well, that actually explains why we have this situation, and it also helps us understand a little bit more about existential import. They give example with zebras. Let's first try this example, and let's go back to this drawing. So why can't you make the inference from A to E? A proposition, all S are P. E proposition is no S or P. So if this is true, how come you cannot say anything about this one? Let's try this example. I like it better. It's about the money. So let's say I have no money. None whatsoever. Would it be true if I say all my money are in my pocket? Because I don't have any money and my pocket is empty. All my money are in my pocket. Is it true? No, why not? Where are my money? Note that it would only be false if my money were somewhere else. Since I have zero money and there's zero in my pocket, that is true. All my money are in my pocket, and all my money are nothing, and so there's nothing in my pocket. So it actually is true. And it is equally true now that none of my money are in my pocket, because I don't have any. So when there's no money, that is both true that all of them are in my pocket, and it also is true that none of them are in my pocket. So that is why if you don't assume existence, you cannot make this inference. Note that if you actually assume existence, you can make this inference, because if I have $1 and it's in my pocket, and I say all my money are in my pocket, it's $1, that's all my money, it's in my pocket, it will no longer be true that none of my money are in my pocket. And equally, if my money are somewhere else, not in my pocket, that will again contradict with all of them being in my pocket. So that is why it is so crucially important whether or not we assume existence. Because in this case, as it shows to you, not assuming existence does not allow us to make any inference here. We will not do that in today, we will do it on Thursday, but once we assume existence, we will have whole range of other relations there, and that's what is known as traditional square of opposition. This one is modern square of opposition, so it's based on Boolean standpoint. We are not assuming existence, and so all we have is just these two relations, contradictory going across, and that's it. For this very reason. So yeah, they are using zebras. With zebras we have the same situation. So to say all flying zebras are zebras is true, because there are no flying zebras. So all of them are zebras. And equally true is to say no flying zebras are zebras, because there's no flying zebras. It's a little harder to see than with the money, but with the money I think it is more obvious example. And yeah, if you think about that, when you have no money, your money is zero, and you have empty pocket, to say all of my money are in my pocket would be true, and to say none of my money are in my pocket would be equally true, because there's simply no money. We call it vacuously true. It's true by the fact that there's nothing there, vacuum. And equally, now, when you talk about O and I, both of them will be false. So to say some flying zebras are zebras would be false, because we're assuming there's at least one flying zebra. And to say some flying zebras are not zebras would again be false, because we are assuming there's at least one flying zebra. Same thing with the money. If I say some of my money are in my pocket, I am kind of assuming and hinting that there's at least some of my money. And that does kind of make it false unless there is at least $1 in my pocket. If my pocket has absolutely nothing, to say some of my money are in my pocket would be false. And equally, to say some of my money are not in my pocket would be false, because some money already does imply there is at least $1 somewhere. Okay, that is how these relations work. How do you test immediate inferences using what I have just told you? Well, it is simple if you understand the rules. And what we are doing here is, note again, this is not a syllogism, but it is nonetheless an argument, very simple argument when you have one premise and one conclusion. And our job here is to figure out whether it's valid. So, we are given some trade spies are not masters of bribery, and therefore it is false that all trade spies are masters of bribery. So what's going on here? We can test that using a square. What we do, and this is the procedure, you figure out where on a square you begin. Some trade spies are masters of bribery is an O proposition, so you begin at O, right here. And you are going to where? All trade spies are masters of bribery. That is A, so you go in here. So first thing you immediately see, it is a contradictory relations, so you actually can do that. If it was going here, you could not do that. Going here could not do that. This is logically undetermined. But here you can. However, you need to make sure that the truth value changes. If this is true, this is false. If this is false, this is true. Now in this case, when we are not told anything, by default it is true. So some trade spies are masters, not masters of bribery, that would be true. And then we are told that it is false, so that one is false. So everything is great. We are going from true to false, and we are making a valid inference. Therefore it is valid. We say it's unconditionally valid. Why it's unconditionally? Well, some of them will be conditionally valid, but that's in the future, don't worry about it. In this case, it's unconditionally valid. Now, we can do the same thing with Venn diagrams. And there's, it's more important to do it with Venn diagrams. There's just one little thing which we are kind of adding here. And this is the following. When it says it is false, these relations, you're still using these relations, but you have to change from shading to an X or from X to a shading. So if it says it is false that all A are B, you, instead of shading, put an X there. This is all A are B. It is false that all A are B. Equally, if it says it is false that some A are B, some A or B would be X here, right? But it is false that some A or B, you have shading. And now we can do the test for validity. This is how it's done. And in fact, let me just do it for you guys on the board so you could see it on the board a little bit easier. Maybe more step by step. I will have to erase all that. Hopefully you remember that and took note of that. Because this is, like I said, this is an important, very important part. Okay, so we need to test some trade spies are not masters at bribery, and therefore it is false that all trade spies are masters at bribery. We did that already with the square, and we already determined that it is valid. So that's not even the question. What is the question? The question is, how would we do it with Venn diagrams? This is how we would do it. Some trade spies are not masters at bribery. Some T are not M. Like I said, by default it is true, so you put true here and you draw the circles for them. And of course, that would look like this, right? Some trade spies are not masters of bribery. Now, your conclusion is therefore it is false that all trade spies are masters at bribery. Well, we will put false in the end because it's a little less confusing this way. All trade spies are false. I prefer to put it in the end. I think it may be a little more confusing to students when it's at the beginning. So, how would all TRM look like? Remember, it would look like this. But it says it is false. So you have to change shading for an X. So the way you will actually draw it is this. You change in shading for an X. And now you can immediately see why it is valid. It's exactly the same picture. You have X here, you have X here. You're going from this to this. Therefore, it is valid. And this is how it's done. We will do a few more examples, but the principle is the same. So yeah, see, that is the same picture as I have on the board, and it just tells you that it is valid. Another example, how could it look like if it was invalid? It is false that all meteor showers are common spectacles, therefore no meteor showers are common spectacles. You want to test that. What do? Well, first of all, since it is false, you will need to replace. What do you need to replace? All meteor showers are common spectacles, would have shading in part 1. You're replacing it with an X. No meteor showers are common spectacles, on the other hand, is true, so you don't change anything here. It has shading in the middle. Now, you can again see that they are different, right? You need an X here, you don't have an X here. The shading doesn't matter, but the shading is also in the wrong spot, so that is invalid. Another example. Now, this is what is known as existential fallacy. And this is another interesting example. Let's again take a look at it on the board to explain you a little bit better what is going on here. So you approach it in exactly the same way. Okay. So you have given all smartphones are wireless devices. And the conclusion from that, some smartphones are wireless devices. So the top one looks like this. The bottom one looks like this. You have a problem. You cannot draw this inference. Now, first of all, every time you're going from universal, and remember this is universal, A and A universal, to a particular, you will have a problem with Boolean standpoint, because it is always going to have no X on top and X in the middle, in the bottom. How do you recognize it? Without even looking here, every single time you will have shading on top and X on the bottom. That will be existential fallacy. You have to remember that. Shading on top, X on the bottom, existential fallacy. Again, for Boolean. Why is it? Why am I keep on saying for Boolean? They don't really explain it yet in 4.3, but you will see later what the problem is. Now, if you think about it from logical point of view, where somebody tells you all smartphones are wireless devices, therefore some smartphones are wireless devices. Doesn't it make sense? Doesn't it sound kind of right? So if all smartphones are wireless devices, wouldn't some smartphones be wireless devices too? They don't have to match exactly, Sarah. They have to have an X in the right spot, and this is why. And I'll explain to you why now. Yeah, that makes sense. But in order to that to make sense, there has to be at least one smartphone, and you have to put an X here. This is what Aristotelian standpoint will be like. You put in an X here, you put it in a circle. That means you are now assuming one thing here. So that will be then valid inference, because you have an X here, you have an X here. Equally, if you have shading in the same place, that also makes it valid, because that just means whether or not there is an X in another place, it will still be valid for our purposes. So it's a little more complicated than them just being the same or not being the same, but you can, for 4.3, you can just say whether or not they are exactly the same. For 4.3, it doesn't matter, anything else doesn't matter, as long as they are the same. Because you can't have both shading and an X at this point. But this is the idea. This is why it also is important whether or not we assume existence, because if we do assume existence of a smartphone, then of course to say all smartphones are wireless devices would imply that some smartphones are wireless devices. It's only a fallacy if you have nothing here. If you have nothing here, then going from nothing to something is always a fallacy, existential fallacy, because you assume an existence of something and you don't know if it exists. And you may say, but we do know cell phones exist. Yes, but that's because we are talking about smartphones. But what if we were talking about something else, such as students who failed the exam or something? You may not know whether they exist or not. And in that case, you would not be able to do it. That's why Boole said, let's just never assume that. Okay. What do you mean you are confused about when to shade? Okay, once again, whether or not to use shading or an X, you get on the very first diagram which we draw at the beginning. For A, you shade this part. For E, you shade this part. For I, you put an X here. For O, you put an X here. Now, if you are told it is false, you replace shading with an X and X with a shading. That's the only addition to that. Otherwise, you always do that. So you do that, but then when you look at it and it says it is false, blah, 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 you replace shading with an X and X with a shading. And you do not do it for the square. You do it for these drawings. For the square, it doesn't matter. You don't have a drawing, right? So there's nothing to replace with anything here. Here, you're just going along the square. But when you, this is two different ways to do the same thing. When you're doing it with the circles, now if it says it is false, you have to replace it. Okay, hopefully when we do exercises, you guys will get it a little bit better. Because that's the best way to learn it. I don't know if me just talking about it would make a whole lot of sense, but if you do exercises, and especially if you rewatch that video later again, I don't know if I'm going to put your section or the other section, I haven't decided yet, but whichever one it is, it's the same material. So you will watch it again, and then you will see how it makes sense. First time you hear it, maybe it doesn't, but second time it will. So, existential fallacy is again fallacy which is committed whenever an argument is invalid merely because the premise lacks existential import. When you have universal on top, particular on the bottom, that is existential fallacy for Boole. Always existential fallacy for Boole. And the best way to determine it is with the shading. Why? Well, let me show you why. So suppose you have situation like this. This is the situation, right? All A are B, therefore some A are B. You're going from universal to particular. Clear. That's existential fallacy. Now suppose you have something like this. It is false that some A are not B. It is false that no A are B. You may think that you're going from particular to universal, but you're not. Why not? Because you're replacing, it is false, you're replacing X with a shading, and that becomes universal. And here you're replacing shading with an X, and that becomes particular. So the best way to determine that is not to go by some or all or whatever, but to draw it and to look what do you have on top and what do you have on the bottom. If on top you have shading and on the bottom you have X, that will be not only invalid, but will be existential fallacy. There is a difference between just invalid and existential fallacy, because some existential fallacies will be valid from Aristotelian standpoint, but if it's invalid, end of story. It's invalid from any point of view. Okay, so this is an example. You look at it, is this in the existential fallacy? The answer should be super simple. Does it have shading on top? Yes. Does it have X on the bottom? Yes. So it is an existential fallacy. End of story. You don't have to do anything else. That's just as easy as that. Shading on top, X on the bottom. Existential fallacy. It's really not as complicated as you might think. This stuff, once you understand it, will be like very easy. But I guess when the first time you hear it, it may be like, oh, a lot of stuff, kind of hard to put your mind around it. Okay. Here's the example with the smartphones again. Shading on top, X on the bottom, existential fallacy. Okay, let's do this exercise. This exercise asks you to do what we did before, which is use that square to determine whether or not this is valid. So for extra credit, give me 3 words, whether or not each one of them valid or invalid. And it could be something like invalid, 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 or valid, invalid, valid, or whatever else. But obviously you have to get it right. Let's see if you understand, because if you don't understand, of course, we will still repeat it and do another exercise. You still not sure? Okay, let's do number 2 together. Let's do it together. So where do you start? Some lunar craters are volcanic formations, so you start in I. And you go to E. Can you do that? And the answer should be very easy. Yes, you can do it. Why not? Why can't you do it? It's a contradictory relation. There is no dashed line. If there is a dashed line, then you cannot do it. If there is a straight line, you can do it. So the answer is yes, you can do it. Now the question number 2, once you can do it, is, are you changing your true value? Because you also have to change your true value. And the answer to this is yes, you change your true value because this one is false and this one is true. So it's valid. That's your answer for the first one. No, content doesn't matter at this point. This is formal logic. We will be paying almost no attention to the content. It becomes just letters for us. In some cases, like, note that when you have to figure out existence, that's one of the reasons why there is such disagreement, because you cannot say whether a thing exists or not without looking at content. But strictly speaking, again, we are not trying not to look at content. The content is replaced with letters. True values also, that's another important point, by the way. True values in formal logic are not really true values. It's not like whether it's true or false. It is more like whether it's black or white. It's just values. You can replace them any way you want. So when it says that it is false, but it is the correct inference, then it will be a true value, which is false. If that makes sense. Okay, you do have to give me all 3. I already gave you 1, so you have to at very least give me the other 2. Well, you can't completely forget the content, because like I said, well, one of the reasons is the existential import, and that of course does create some problems. But in the same time, the further you go in logic, the less content, the less it matters what the content is, because it just becomes a bunch of notation. And this is what computer language is. Computer language is just a pure formal logic. It's just notation. And then you can put anything in there. Okay. Well, that is correct. I hope everybody else is also following along. So yes, again, the 2 is valid and the other 2 are not valid, because going from A to I is illegal. This is dashed line. And going from E to O, E to O, yeah, E to O is again illegal, and again it's invalid. So remember, whenever you have the invalid relation, it's always going to be invalid. But for these two, there's kind of like two-step process. You have to figure out whether it's valid, whether it's allowed. But then second step, you also have to make sure the true value changes to the opposite. If it doesn't, it again will be invalid. So for example, if you have A true, therefore O true, that will be invalid. Because even though this is allowed, but you do not change your true value. But if you will have A true, therefore O false, now that is, on the other hand, valid. Okay, so this is additional requirement there. But otherwise, you just follow this square. Okay, Christian, let me see. What's your force extra credit? Good job. Okay, now let's go to, this is the answer, valid, invalid, invalid. So you can do exact same thing now with Venn diagrams. And you will surprisingly get exact same answer, valid, invalid, invalid. But what I actually want you to do is to draw them, so you could understand how you can get to this answer without the square, with just the diagrams. And so for the extra credit here, you have to again give me the answers. To make it a little bit easier, let's do number 2 together. Let me help you out, because you guys may be again kind of losing it. So number 2, we already know it is valid, right? We already determined that. But let's see. It is false that some lunar craters are volcanic formations. So some lunar craters are volcanic formation, false. How do we draw that? We have two circles, lunar craters, volcanic formations. But if it was not false, we would do what? Put an X where? In the middle. But since it is false, what do? We shade it in the middle. We replace X with the shading. Okay. How about next one? No lunar craters are volcanic formations. And that one is true. So here we actually don't have to replace anything with anything, since it is true. How does no LRV look like? It is shaded in the middle. So it's just exactly the same picture in this case, and therefore it is valid. Like I said, at this point, if it's the same, it definitely is valid. You don't have to worry about anything else. So you know already the other two are invalid, but I actually want you to give me the answers with how do you draw that. So for example, in this case would be the first one has middle shaded, the second one has middle shaded, valid. 2 is correct, this like I already told you. 3 is correct in this case too. There's a problem with 5. What is the problem with 5? It is false that no jazz musicians are natives of New Orleans. Well, let's do it together on the board. So again, you are given, it is false that no jazz musicians are native of New Orleans. No J R N. False. How do you draw that? 2 circles, J and N. Without false, how would it look like for no J or N? You would have shading in the middle. But it is false. So you replace the shading. So you would have an X in the middle. That's the first one. The next one, the conclusion here is some jazz musicians are not natives. So some G are not N. And that one note is true. So you don't change anything. How would it look like in true? You would put an X here. And you're not changing it to anything, therefore there's an X here. See? That's the correct answer. So why is it shaded in the middle in your case? I have no idea. It's not, first of all, middle. There's nothing in the middle. And it's definitely not shaded anywhere. So this is how it's supposed to look like, again, from the book. This is the one, this is the one, this is the one. Note also, and this is also important, that this is one is not just invalid, it's existential fallacy. It's the only one with existential fallacy. Why? Because you're going from shading to an X. This one is not existential fallacy, this one is not existential fallacy, this one is valid, this one is invalid, but this one not just invalid, but also is existential fallacy because of that. Okay, don't doubt yourself too much. Okay, this is an easier extra credit. Try that one. Just 2 diagrams, and again, just tell me what do they look like. No inferences of any kind. Just 2 diagrams. Remember how we did at the beginning. Note that if it says false here, you don't actually have to change shading for an X or X for shading. You don't have to worry about that. Why? Well, you're not even drawing anything. So why would you change anything? You're just following the lines. Okay. And the last one. Well, good job, Sarah. Well, I know that you guys already have maximum. I know you actually understand, but I'm just worried about the rest of, even though there's very few people in class even right now, but there's still more than 4, and still nobody else wants to do that. Okay, that's a super easy answer. Invalid, valid, invalid. I thought that was really clear. I don't know what exactly the problem is. Again, this is very simple. You find where you are, you find where you're going. If the line is dotted, that means you cannot do it, it's invalid right away. If the line is not dotted, they have to change the truth value. So in this case they do, right? This one's false, this one is not, so it's true, so it changes, so that is okay. For example, if it said no credit cards are things that contain holograms, therefore some credit cards are things that contain holograms. Would it be valid? No, it would not be valid. And what else would it be? Existential fallacy. Yes, because this is universal, this one's particular. You can see it even without drawing anything. This one's universal, this one's particular. Now, it is false that no credit cards are things that contain hologram is no longer universal, but like I said, if it didn't say it is false. So it would not only be invalid, it would be existential fallacy. Okay. Well, the last one I'm afraid to even give you because that requires you to draw the circles there. But, well, try your best, I guess, for the remaining few minutes. And let's see if anybody gets that. Note that the result will be exactly the same. This is exactly the same 3, right? They will be invalid, valid, and invalid. That's not what I'm asking, of course. What I want you to do is to do the circles, to do this. What's on the board, right? That's how you're supposed to do it. And you're supposed to tell me something like, in this case, X in the middle in the first, X on the left side in the second. That's what I'm kind of looking for. Okay, we don't have much time for that. This would be the answer. So that we already did that, right? This is the one. Is it the one? No, that's a different one. But amazingly, it looks exactly the same. Anyway, so some CRA, you put X in the middle. Some CR not A, you put X on the left side. That, of course, would be invalid. No CRT, you would be shading in the middle, but it says false. So you put in an X there. And some CRT, you put in an X here, it is valid. Can you see it is valid? The same. Some S are not C, you would be putting an X here, but it is false. So you're replacing it with a shading. Some S are C, again, you would be putting an X in the middle, but it is false. So you, again, replacing it with a shading. And again, you can see it's invalid. As you can also see, none of them is existential fallacy. Because even though these two are invalid, but you're not going from shading to an X. Going from X to an X here, shading to shading here. Okay, that's all we have time for. Hopefully you got as much as you could out of it. But we'll continue next time. It'll get a little more complicated, but not too much. Next test is on 29th. We're almost actually done with the stuff. Next week we'll have the review, and then we will have the test. So the last bit of material will be on Thursday, 4.5 and 4.6. We're skipping 4.4. You don't need that. It's a little too complicated for you guys. So just 4.5, 4.6, and then we have the test. Okay, so I will post the practice test on Thursday after class. And you can do it again over the weekend.